Let's review the generator from your intro physics course, since we're discussing Faraday's law in this chapter. And in this diagram, you have a loop here which is turning upward here to the left. That little arrow is showing that. And the magnetic field is pointing upward. So here you have a magnetic flux going upward that you're actually decreasing by turning that area sideways. And when you do that, you set up a current that's going to produce a magnetic field that is in the direction of the magnetic field, because it wants to help it, wants to keep it going, wants to do the opposite of what you're doing. So using the laws, the induced electromotive force, and we'll talk about this more in our course, this is what gets your current moving, and this E dot dl, we'll set that equal to that epsilon for now and come back to it. If we take the negative derivative of the flux here is the magnetic field through the area, but the area, see, is tilted. So if we have this tilted region, then the n hat points, perpendicular, the magnetic field is going straight up. So you basically want your cosine of that theta, or think of it this way, project the area down, that's then perpendicular to the magnetic field that goes up, and it's a cosine theta. That's the relevant area. So you can do it that way, or you can set it up formally. The B vector is bk hat, and this a vector for the dA for the area has a little n hat, and k dot n hat gives you that cosine theta, and then you have BA cosine theta. So that's the situation for your magnetic flux, and then you take your derivative, and then the simple case here, if you're turning this around, here you have sinusoidal motion, so you take your theta to be omega t, and then when you take your derivative, so your B is constant, capital A is already been taken here as a constant, since your cosine theta is what's going to vary as the projected area changes, and the D dt on the cosine, when you have the omega t in there, the derivative of the cosine is negative of the sine, and then you pull out the omega. Two minus signs cancel, and you get this result, BA times the sine of omega t, and that's a sine wave generating alternating current. And if you have n loops, you reinforce things and you multiply this by n. So that's the electromotive force that's set up in the wire to get your current moving, and that's your generator or dynamo and Faraday's law.